In the last lesson, we evaluated expressions by traversing the expression tree in depth first order. Let's now see how LWPython follows the same evaluation strategy. LWPython uses two stacks, the expression stack to store the expression tree, and the value stack to store evaluated outputs. Both stacks are initially empty. Here's a high-level description of the evaluation process. 1. Push the expression into the expression stack and an empty child stack to the value stack. 2. If the expression has any operands, push the operands to the top of the expression stack. 3. If the expression is an atom, then evaluate it and push the result to the value stack. Then pop the expression from the top of the expression stack. 4. If the top element of the expression stack is empty, then Python has finished evaluating the operands, so use the values at the top of the value stack as input and evaluate the operation in the next element of the expression stack. Let's look at an example to understand how this works. Suppose we want to evaluate the following expression, x plus 3. First, we push this expression to the top of the expression stack, and an empty stack to the value stack. Every element in both stacks is also a stack, so we're looking at 2D stacks, or a stack of stacks. The expression stack currently has one element, and that element is also a stack with one element, x plus 3. The brackets indicate that the element is an empty stack. Thus, the value stack currently has one element, and that element is an empty stack. Next, LWPS inspects the top element of the top element in the expression stack, which is x plus 3. This expression contains two operands, x and 3. LWPS will push these operands into the expression stack, and a new empty stack into the value stack, as follows. Notice that the expression stack now has two elements. The top element is also a stack with two elements, x and 3. This inner stack is displayed horizontally. X is actually on top of 3. LWPS again inspects the top of the top element. The top element is the stack x3, and the top of this stack is x. Since x is an atom, LWPS will pop x, evaluate it, and push the value into the top element of the value stack. Suppose that x is 2. Then 2 is pushed into the top of the value stack, as follows. Note that the top element of the value stack is no longer an empty stack. Next, LWPS again inspects the top of the expression stack. 3 is a constant, so LWPS pops 3 from the top of the expression stack and pushes it into the top of the value stack. And the result is as follows. The top element of the expression stack is now an empty stack. Thus, all operands have been evaluated. LWPS will now evaluate the operation x plus 3. LWPS can see that the operation is an addition, so it simply adds the elements at the top of the value stack, 3 and 2. LWPS also pops both the expression stack and the value stack. Further, the expression x plus 3 is popped from the new top element of the expression stack. Then LWPS pushes the sum, which is 5, into the top element of the value stack. And here's the result. Evaluation is complete, and the output is 5. The output is always stored in the top element of the value stack. Please feel free to run this example in the simulator below to see this algorithm in action. Then try running more complex expressions to highlight the order in which the operations are evaluated.